do you understand by stress and strain? So the term basically stress, everyone know stress. Basically, stress is the load upon area. But what do you understand by pressure? Pressure is the normal force per unit area. Everyone know pressure is the normal force per unit area. But stress is the force per unit area. Okay. Means sigma is equal to P naught upon A. Suppose here sigma is the stress is equal to force means P upon area. Okay. It depends on original area or instantaneous or area. Instantaneous means varying area or A naught means original area. Okay. So sigma is equal to P upon sigma is equal to load upon area means original area. And okay. And A naught is the original cross section area. L naught is the now and strain is equal to delta L upon L naught. Okay. So strain is equal to everyone knows basically elongation per unit length is called the strain. Everyone know basically strain is the dimensionless quantity and it is defined as the elongation per unit length is known as the strength. Sorry, strain. It is like tensile strength or compressive strength. It may be dependent on the figure or the components. So remembering that while the length of the rod changes, it's the cross section area. Suppose this is the bar. This is the bar or the simple the this is the bar okay, or the rod. Okay. So while the length of the rod or bar changes, suppose this is the length is the original length L naught, okay, and this is the cross section area, okay. Suppose the diameter D1 and diameter same diameter D and D, and area is the A naught, okay. So in that case, suppose we want to discuss here, sir, while the length of the rod changes, its cross section area also changes. If this original length is changed, suppose this goes to L, then its cross section area A naught here, it's also changed to A. Okay. So just a start, I want to say that while the length of the original rod changes, so its cross sectional area also change. You know, hence
Yes.
after a load P has been applied, suppose you have after load P or simple compressive or tensile, it depends on condition. So after load has been applied, then area would have changed to A. Okay, and A is different than A naught. Suppose so here, suppose we want to say that suppose A area is the after changing is A naught, and here carefully. Suppose area A is less than A naught if P is tensile, less than A naught if force or load is tensile. If P is tensile, okay, this is the tensile in nature.